video, I'm going to show you how to use bending moment diagrams to solve your reactions quickly. Rather than using equilibrium equations, which takes time, instead you can quickly draw your bending moment diagrams and using the slope of the bending moment diagrams to derive your reactions. Let me show you how to do it. So first of all, you have to be familiar with some basic shapes of the bending moment diagram, such as when the beam is loaded with the UDL, and your bending moment diagram is going to be a curved line, parabolic shape. And when the beam is loaded with the point load, your bending moment diagram is going to be a triangle, a straight line from one point to another. So that's starting from the from point E, right hand side. We've got 3 kilonewtons here. The cantilever length is 2. We know straight away this is going to be a straight line. At this point here, hogging moment here is going to be PL 2 times 3 equals 6 kilonewtons meters. So this point here is 6. In the middle here, we've got a point load over between A and B, so that we know for a fact that the bending moment diagram is going to be an upside down triangle. But let's leave it for now because we can looking at the left hand side is simpler. Under the UDL, the cantilever end, the bending moment diagram is going to be a parabolic shape. For me, my preference would be I would connect this point C using a dashed line, because at point C, the bending moment is 0. Using a dashed line is because I know this point C to A is going to be connected. And whether it's going to be a straight line or parabolic shape, depending on the load. Right here, the load is UDL. So the bending moment diagram at this point here is going to be a smoothed curve. It's concave down because the load is pointing down, so concave down here. And next, we know from this point here, point A is going to be hogging as well. So the moment here is omega L squared over 2. That gives 5 times 2 squared is 4 divided by 2 equals 10. So this point here is 10 kilonewtons and this point here is 6. Same thing, my preference, I'm just connecting these 2 dots together using a dashed line. And the point D here is pointing in the middle. Using geometry, we get this point D is 8 because 10 is top, 6 is below, and 8 is middle. And because we've got a point load here, as I said, this point here, I just drawn a point here. It could be up here, but let's just assume it's going to be below. So which is connecting this point from A to D and the D to B. And this is your bending moment for point D. And this point value, the lowest value here, is going to be, actually for this vector, this length here, is going to be PL over 4. That is 10 kilonewtons times distance is 2 plus 2. 4 divided by 4 equals 10. So the overall vector is 10. However, we've got 8 kilonewtons above the point. This 8 kilonewtons meter is this value here. This is 8, which means you have 2 below it. This is 2. That giving this lowest point here is 10 minus 8 equals 2 kilonewtons meter. So this has completed the bending moment diagram with the maximum bending moment being 10 kilonewtons meter. And then you can design for this 10 kilonewtons meter for the max. And then next we need to work out the reactions for A and B. To do this, we can use the slope method. Because we know from B to E, this triangle here, you've got a slope. Let's call the slope K1 is going to be your 6 kilonewtons here, and your distance is 2. So this triangle slope is 6 by 2 equals 3. and which is exactly the same loaded point at E, 3 kilonewtons. So we know for a fact that at the reaction B on the right hand side, there's a 3 kilonewtons. Then we need to figure out the left hand side as well, because we've got the triangle on the left hand side. And this triangle, the slope, we call it K2, equals your 6 kilonewtons to the top and 2 kilonewtons to the bottom. And your triangle here, the slope is going to be 6 plus 2 divided by 2 equals 4. Therefore, we can sum up 4 and 3. Your reaction B is going to be 7 kilonewtons. Now let's move on to the left-hand side at point support A. Same thing, we can do it with right-hand side. Let's look at the right-hand side first at point A. It's got a triangle, and easy to work out. That's called K3. We've got a point load, and the top is 10, and the bottom is 2. So this vector here is 10 plus 2, divided by your distance is 2, equals 6. And on the left-hand side, because it's not a triangle, we cannot use the slope method because the slope changes to a parabolic shape. Every point here, your slope changes. However, we can just use this UDL times your distance gives you 10 kilonewtons. Straight away, that's because all those loads are loaded on the left-hand side of the support A. So left-hand side is 10 kilonewtons, and the right-hand side is 6 kilonewtons, and we combine together. So your RA is 16 kilonewtons. That gives our total reaction force is 23 kilonewtons. We can do a simple check on that. We've got a 5 UDL times 2 is 10, plus 10 is 20, plus 3 is 23, which is correct. So this way is much faster and quicker than using equilibrium equations. The more you do, the more often you visualize your bending moment diagrams and you know when to use parabolic lines and when to use straight lines. If you could remember and memorize all those lines, you can quickly get your bending moment diagrams drawn fast. And based on the bending moment diagrams, and then you can work out your reactions based on the slope method. And this is how you do it quickly. I'm hoping this video would be a benefit to you. If you have any questions, just make a comment below. And thank you for watching.